Hello everyone, welcome to today's video. So in this today's problem, we shall actually see an interesting combination of two topics. That is, one is from trigonometry and the second one is combination itself. So the first question, the first part of the question says, if cos theta by 2 plus cos 2 theta by 3 plus cos 3 theta by 4 plus so on plus cos n theta by n plus 1 is greater than or equal to minus 1 by k minus sin square theta by k plus sine of 2n plus 1 theta by 2 of n plus 1 sine theta, then find the number of different rational numbers. Fine, we need to find that number of like number of different rational numbers that p by q that can be found. It's not like we must find all the rational numbers, we just need to find the number of different rational numbers that are possible that can be found where p and q belong to 1 2 3 so on till k. So if we know the value of k, then this can be solved easily because we can know the value of k, and then finding the number of rational numbers is not that difficult task. Fine. So it's all about finding this value, like the k value from the very first part of the question. To be honest, this can be solved further. This right hand side part, so this so-called part can be solved further, and we can actually come to a conclusion that this so on, this LHS left hand side is actually greater than or equal to minus half. Fine. So the solving procedure of all those things, I am not showing all those things because it's somewhat out of context, as well as it takes a lot of time to put all those things and make sure the video is limited to 30 minutes. So that's the reason I've not taken all those things. Like, I've not simplified to the last step, but I've just taken someone, like I've just limited to the solution part, like this so-called right hand side of the inequality. Like this is maybe a fourth or fifth step from the last to the solution. Fine. So before coming to minus half, we have this fifth step, and then after solving it we could get to the minus half. So I'm using this so that we can have the value of k and we can find the value of p by q. Fine. uh, so yeah, so how do we proceed? So first of all, we must actually make sure like we are so clear about what are we doing. So for the n is equal to 1, for n is equal to 1, we get that to be cos theta by 2. Fine. So for n is equal to 1, we get this to be cos theta by 2, and we know that cos theta, the least possible value of cos theta is minus 1. So this is minus 1, so it's greater than or equal to minus 1 by 2. And for n is equal to 2, LHS would be cos theta by 2 and plus cos 2 theta by 3. Fine. And what is cos 2 theta? Cos theta is equal to 2 cos square theta minus 1. So that's what I've written here. And now you can see that this is quadratic equation in cos theta, isn't it? Actually, like this is an expression, to be honest. It's not an equation. This is expression, because we have not equal to we have not kept any equality sign to the right hand side of it or left hand side to it, and we are not equating it to something. We are just talking about this. So this quadratic equation cos expression is cos theta with coefficient of cos square theta greater than 0. The coefficient of cos square theta is 2 by 3, isn't it? And which is actually greater than 0. So this is an open like upward facing parabola. So we can find the minimum value, but the maximum value is infinity. So this can be, but so we actually need to understand that the infinity in this case is not valid, because cos theta maximum value is 1. Fine, it cannot go further. So it is 1 by 2 plus 2 by 3 and minus 1 by 3. So this is what like this is the maximum it can go. So you can just solve it to get the maximum value. It cannot range up more than that. Fine. So but we are not bothered about maximum value. We just need to find the minimum value. Fine, because the discussion is all about the minimum, isn't it? Like greater than or equal to. So yeah, this is quadratic expression cos theta. So coefficient of cos square theta greater than 0. So minimum at cos theta occurs at minus b by 2a. So what is b? 1 by 2. So minus 1 by 2 divided by 2 of a. So 2 of 2 by 3. So that is minus 3 by 8. And now minimum is, you can just substitute minus 3 by 8 in the place of cos theta. So you'll be ending up with minus 3 by 16 plus 3 by 96 minus 1 by 3. And when you solve it, you want to get this to be minus 47 by 96. I'm not sure, like I've checked it for twice and thrice, the calculation is perfect, but still at times will be checking for twice or thrice, we finally end up wrong. So please, I request the viewers to check from your side also, but this doesn't matter as of now. So this is just for the like idea, like what are we actually trying to find. So now we shall come to the generalized form, that is cos and theta. So what is cos and theta? Basically here we have this cos and theta term, right? Cos and theta by n plus 1. This is the Tn. So we must now look on to the generalization part. So we must actually try to, because this is n is equal to 1, it is easy cos theta by 2. N is equal to 2, it is easy cos 2 theta by 3. N is equal to 3, that is also easy because we know the formula of cos 3 theta in terms of cos theta. So that is also easy. But when you go up to cos 4 theta, cos 5 theta, substituting that in the form of cos theta, it's a very complex way. So better we try to go for generalization. So cos n theta is equal to sine of 2n plus 1 theta minus sine 2n minus 1 theta divided by 2 sine theta. So how did I end up with this? So basically sine c minus sine d formula is 2 cos c plus d by 2 sine c minus d by 2, isn't it? So sine of 2n plus 1 theta minus sine 2n minus 1 theta is, you can just substitute c as 2n plus 1 theta and d is 2n minus 1 theta. So when you do that, we get 2 cos n theta, and sin c minus c is 2n plus 1 minus of 2n minus 1. So that is 2 by 2, and that is sin theta. And when you just shift this 2 sin theta to the left hand side of the equation, we get sin 2n plus 1 theta minus sin 2n minus 1 theta divided by 2 sin theta, and which is equal to cos n theta. So that is what, that is how we have got this. So cos n theta is equal to sine square of n plus 1 theta minus 2 sine square n theta plus sine square n minus 1 theta divided by 2 sine square theta. So how did I get that? So very first step is just multiply sine theta to the numerator and denominator. Why are we doing all these things? Just to get the much simplified version. Fine. We need to come to such a way so that we simplify the equation and we actually cancel out the terms. We must look into all the different ways possible in solving an equation, solving an like simplifying an expression, and using that to find the required inequality. So when we multiply by sine theta to the numerator and denominator, so this is how it appears: sine 2n plus 1 theta into sine theta minus sine 2n minus 1 theta into sine theta divided by 2 sine square theta. The reason behind listing this problem as tough difficulty level is that the logics, fine, it's not that obvious to get some logic and then proceed. There are plenty of ways in which a problem can be looked at. So we just need to look at the perfect logic so that the simplification gets easier and all those stuff and time factors and all those things. So that's the reason I've listed this problem as tough, because it's not that easy to get this logic. Fine. So sine 2n plus 1 into sine theta minus sine 2n minus 1 theta into sine theta divided by 2 sine square theta. And now this is another formula that we need to actually look at. So sine a plus b into sine a minus b is sine square a minus sine square b. So in this very first case, in this case, the a is n plus 1 theta and b is n theta. So that's the reason we are able to write it as sine square of n plus 1 theta minus sine square n theta. And when you come to this case, this is a is n theta over here and b is n minus 1 theta. So that is the reason when you add them up, that is sine square sine a plus b into sine a minus b, right? So this is of that form. So when you just simplify it, you get this like a plus b is equal to 2n minus 1 and a minus b is equal to theta. Fine. When you just add them up, you get this, sorry, this is yeah, this is 1. So you get 2n and a is equal to n. And so when a is equal to n, you get that b to be n minus 1. So that is the reason we have written it. So a is equal to n theta and b is equal to n minus 1 theta. So you can just write it as the sine square of n plus 1 theta minus 2 sine square n theta plus sine square of n minus theta divided by 2 sine square theta. And now this is the what is this value? Actually this is cos n theta. So we must actually remember this. This is cos n theta, but in our generalized term like Tn, we have n plus 1 in the denominator. So we need to divide this by n plus 1. So when you just divide this by n plus 1, so we get this here n plus 1 here, and this is n plus 1. So this is all about the Tn. Fine. This is all about the Tn, the nth term. What about 1? So it varies. What about 2? It varies. Like you can just put like k is equal to, n is equal to 1, 2, so on, and then finally we have n over here. So we can just generalization, we can write this as like the sigma k is equal to 1 to n sine square of k plus 1 theta minus 2 sine square k theta plus sine square of k minus 1 theta divided by 2 sine square theta into k plus 1. Fine. From k is equal to 1 to n. Now we can just substitute k is equal to 1, 2, 3 and so on, so that it results in a simplified expression. So that is what it means, like that is how we need to think. So we just need to, once we simplify it into something like Tn, like this is sigma Tn, which is equal to Sn of LHS. And now we actually need to make sure we cancel the terms. Okay, so a telescopic series type. So we must actually make sure it happens. But to be honest, it doesn't happen here. But the thing is, it simplifies. Fine, it is not a telescopic series. You cannot cancel the terms. But thing is, you can actually simplify. So thing is, sigma k is equal to 1 to n cos k theta divided by k plus 1 is greater than or equal to 1 by 2 sine square theta of sine square 2 theta by 2 minus 2 sine square theta by 2 plus it is 0 here. Like we shall do one thing. We shall actually write this equation here. We shall actually copy this equation so that we don't end up in confusion. And just do it. Yeah. So yeah, this is the simplified expression. So when you put k is equal to 1, we get sine square 2 theta divided by 2. We have taken the 1 by 2 sine square theta outside the bracket, so outside the sigma. So and then when you keep k is equal to 1, this is sine square 2 theta and 2 sine square theta and sine square of 1 minus 1, that is 0. So there is no term out here. And then coming to the second part, we have when you keep k is equal to 2, it happens to be sine square 3 theta minus 2 sine square 2 theta plus sine square theta by 3. And when we substitute k is equal to 3, we get sine square 4 theta by 4 minus 2 sine square 3 theta by 4 plus sine square 2 theta by 4. And when 4, we get sine square 5 theta by 5 minus 2 sine square 4 theta by 5 plus sine square 3 theta by 5. The reason why I'm actually why I substituted these many terms till k is equal to 4 is I want you people to get a better understanding of what is actually happening here. So I shall just zoom out if possible. Yeah, fine. And till the end point where we keep k is equal to n minus 1. Fine. When we have k is equal to n minus 1, the very first term appears to be sine square of n minus 1 plus 1. So n theta divided by n minus 1 plus 1 n minus 2 sine square of n minus 1 theta by n plus sine square of n minus 2 theta by n. And the very last term, that is k is equal to n, we have sine square n plus 1 theta by n 10 plus 1 minus 2 sine square n theta by n plus 1 plus sine square of n minus 1 theta by n plus 1. So this is all about it. And now you can just check here. Let me use this. So sine square 2 theta. First of all, let us look at sine square theta. Okay, we have here sine square theta term and here is sine square theta term, and nowhere else we'll find sine square theta again. So we can just simplify them. So it appears to be minus 2 by 3 sine square theta, and then sine square 2 theta. This is here we have one term, here we have one term, here we have one term. So we can just take the LCM and we can solve it. We will be ending up with sine square 2 theta by 12. And now come to sine square 3 theta. Here we have a sine square 3 theta term. Here we have a sine square 3 theta term. Here we have a sine square 3 theta term. So, and that solves to be sine square 3 theta by 30. So don't try to look at a generalization of the terms. Fine. It's too difficult. It's not possible even. So thing is, you actually need to solve them up. So what do you mean by solving? So you can just check for the terms sine square n theta. Fine. It starts from here and it ends up here. Fine. There's no you cannot expect n theta here because we are limited to k is equal to n itself. We are not limited to k is equal to n plus 1. We cannot go to this. We can just go to k is equal to n. So we'll be ending up with this term and this term, and when you simplify it, we'll be ending up with sine square n plus 1 theta by n plus 1. And you can even check for n minus 1. Fine, we have n minus 1 theta over here, n minus 1 theta over here, and here also the before step, step, we can find sine square n minus 1 theta in this position. So I'm leaving it as a task for you, and when you solve this, you'll be ending up with such an expression, like this expression. So this is how you need to actually come to a conclusion. You cannot try to find the generalization. Fine, you cannot actually try to link up this term with this term and this term. You cannot actually try to find the relation between these two. So this is actually greater than or equal to minus 1 by 3 plus cos square theta by 6 plus sine square of n plus 1 theta minus sine square n theta divided by 2 of n plus 1 sine square theta. Thing is, first of all, just take sine square theta outside the bracket so that you can cancel up the terms. Sine square 2 theta is 4 sine square theta cos square theta. So you can just cancel the sine square theta term, and 2 gets cancelled, 2 twice of the 4, so twice and 6 gets cancelled, so you'll be remaining with cos square theta by 6. And the remaining part that I'm giving as a task for you people to solve it, it's not that difficult, let me be honest. It's very easy. You just need to identify the logic that is applying b here, and now you can just find the general final expression to be in this way. Minus 1 by 3 plus cos square theta by 6 plus sin square of n plus 1 theta minus sin square n theta by 2 of n plus 1 sin square theta. And this again applying the same formula, like you can just shift it, cos square theta, we can just apply that to be 1 minus sin square theta, so it appears to be minus sin square theta by 6 plus sine of 2n plus 1 theta divided by 2n plus 1 sin theta. You can just apply all the formulas that we have described earlier just in this video. So when you compare, we can see that k is equal to actually 6. Fine, k is equal to 6. So we are done with the trigonometry part, and now the combination part is, so p by q should be formed from the numbers 1 2 3 4 5 6. I think it's an easy task for many of you people, but some may have actually confusion, may have actually end up with confusion. I just want to remove that. So p have 6 choices, q have 6 choices, so totally 36 choices, isn't it? 36 ways of making numbers. It's not all are not different. Fine, it's just like you're choosing it without any restriction and forming numbers. So you can get different, you can get same numbers. That's what we must subtract now. So p can take 6 numbers, q can take 6 numbers, so 6 into 6, 36 different like 36 total number of possible ways. And now we need to subtract those cases which gives the common p by q value, isn't it? So if p is equal to q, then 6 by 4, 6 by 2, 6 by 6. This actually simplifies, isn't it? This simplifies to 3 by 2. And when you have p is equal to 3, then you'll be facing this value, having this value 3 by 2, isn't it? So these are all these are known as common terms. So 6 by 2, when you just cancel up, you get 3, and 6 by 6 1. So you're getting 1 year, you'll be 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 getting 1 year. So totally we have 1 2 3 4 5 6. So 6 cases we have in which we are actually getting 1, and there are also the same conditions. So what we must do is we must actually subtract 6 and then add 1, because it's not like we must subtract all the ones, it's like we must subtract all the common ones. Fine, there are 6 ones here, so if you subtract minus 6, will be like there will be no 1 in your answer. So now just put another 1. This one indicates the number of ones now. Fine, so 1 indicates that we have 1 in the p by q value. So this is how you need to make sure, like you take out the common terms. Fine, and when you come to 4 by 2, so this appears to be 2. Fine, and in the same way we have 2 here, so we must actually remove all those common terms and just add plus 1, so that we are actually putting at least one term in the required cases. So q is equal to 6, 2 by 6, 4 by 6, and 6 by 6. So this cancels out to be 1 by 3, and we have 1 by 3 over here also. So we can just subtract these common cases. So when you do all those things, we are will be left with possibilities as 36 minus 13, that is equal to 23. So there are 23 possibilities of finding p by q value, like rational numbers. So you must actually keep this logic in your mind, like if you have rational by rational, rational by rational will give you rational. Right? So many people will be confused on this fact, but yeah, you need to keep this fact in your mind, that rational by rational will be rational. And yeah, this is all for today. So I hope you guys actually enjoyed this problem. So this is all about combination types. I'm actually focusing on this type of problem so that we can actually cover 2 problems in one video. Find 2 different concepts, one from the trigonometry and from the combinations, and we can actually combine them, and we can make a tough level question, or at least a good looking question. Fine, it's not just like there's no logic or something like that. There are a lot of indeed logics and formulas and all those stuff, so it makes a problem good looking. So that is all I expect like when I make a combination type problem. So thank you guys for watching this video. Stay tuned.